are very pleased to have Philippe Dejean from IRT Saint-Exupéry with us today to present the tool called 𝗂𝗽𝗱, and that is helping with explainability. So Philippe, I will give you the floor.
Thank you. So hello everybody. I will introduce 𝗂𝗽𝗱 with a focus on 4 notions we discussed during the French program Confiance.ai. I will explain the concept of 𝗂𝗽𝗱 and its usage as a benchmark tool. And I will detail the results in terms of plots, information provided, and reports. And then I will present the current limitation of the future development we propose. Explainability and interpretability are often confused and used together for the same concept. But explainability concerns the transparency of the system, while interpretability pertains to the human capacity to give meaning to explanations. Understanding and comprehensibility emphasize the importance of the human acceptance and criticism of explanations. During the Confiance.ai program, we worked to differentiate these 4 terms and converge to these definitions. Explanations are the results of an algorithm. It aims to provide a justification for the model decision, often in response to the requirement for transparency or regulation. Understanding is a human acceptance of these results as a correct explanation, not necessarily useful, just correct. Comprehension is the human process that considers explanations according to its knowledge of the data and the model. And that interpretation is the last human process that considers its comprehension of the explanation according to its knowledge on the application domain. 𝗂𝗽𝗱 must be considered as a benchmark tool, as it facilitates the use and the creation of comprehensive and comparative reports on explainability methods for your use case. 𝗂𝗽𝗱 must be considered too as a comprehensibility tool. It is part of this mediation tool, allowing to implement and use explainability method in a guided way, facilitate the adjustment of their parameters, and facilitate the comprehension of the explanation. If we consider 𝗂𝗽𝗱 as a benchmark tool, 𝗂𝗽𝗱 is a framework working that facilitates the use of the main explainability libraries available in open source. Currently, it integrates 6 libraries we will call KAA libraries and offer 42 methods for different data type, model format, or problem. It allows to apply the method and metrics of these libraries for model verification and design. 𝗂𝗽𝗱 is built around a kernel offering a text-based user interface to manage and prepare a benchmark. Use case and KAA libraries are hosted in plugins you can activate as you want. You can also develop your own KAA library and compare its results with others during the benchmark. In a classic explanation study for model validation, access to the method and metrics of library requires relatively great knowledge of the APIs, more or less well described in their own documentations. You also need to know the implementation of the use case model and the function to access data. With these elements, the development of Python code for the implementation of interfaces between libraries and use case can be relatively complex, and often carry out for only 1 or 2 methods for a single library for lack of time. Finally, each run that can be summarized by a triplet use case method and parameters is carried out individually, necessitating the sorting of results for subsequent comparisons. 𝗂𝗽𝗱 facilitates benchmark by integrating methods and metrics for explainability libraries into plugins via uniform interfaces. The knowledge of the APIs of the main library is no longer necessary because their dedicated plugins are provided in 𝗂𝗽𝗱 distribution. Thanks to this system of plugin, it allows to integrate your own library in order to control and use it in the framework. For your use case, only the function for data reading, model reading, and inferences must be known and developed to integrate your use case through a plugin. If we consider 𝗂 as a comprehensibility tool, its first objective is to make explanation easier to comprehend. To explicit this aspect, I usually propose the example about Renault welding use case. Welding are classified by the model as OK or to be retouched. This example is based on 3 images of the same kind of welding. The use case, for the use case, we use 2 methods, occlusion and rise, from Explic library to provide explanation. We can see that the hotspot in red color focuses on welding. This means that perturbation on images generated by the method in the red zone have a greater impact on the model decision than those in the blue zone. But for the last image, and often for the bottom right, we show that explanation seems to be inverted. The welding is under the cold spot in blue color. All the rest of the image seems contributing to the model decision. If we remember the 4 definitions, these explanations are the result of the use case of the occlusion and rise algorithm. We understand these results because we can identify the meaning of the color red spots, but we cannot comprehend the last explanation by comparing it to others. And of course, we cannot interpret this explanation. But when we consider other information, the ground truth, the model decision, the prediction score, this explanation of the last image are correct. Indeed, the model does not give a good decision and the prediction score is low, only 50%. So even a small perturbation on the welding zone changed the model decision from wrong decision to good decision according to the tool. The explanation highlights this phenomenon. So we can comprehend this explanation and we can act accordingly. To understand and comprehend this kind of explanation, 𝗂𝗽𝗱 provides plots enriched by all information it has, with several color map or graph for tabular problems to highlight events. In this example, we can show that the plot is on the image size as the model requires. The range of the explanation is mentioned, as well as the truth, the prediction class, and the prediction score. To compare results and write an efficient benchmark report, 𝗂𝗽𝗱 saves all data and plots in separate folder according to libraries, methods, and parameters values. Each run generates on demand a contact sheet in which you can show all the results with information on ground truth, inference, and explanation. The plots can be made on both image size with which the user is familiar and the size needed by the model to be more precise. At the end of your benchmark work, 𝗂𝗽𝗱 can aggregate all the results it generates in a single and complete benchmark report containing a small description of the method and the parameters, all all the plots reported in the contact sheet, and all the metrics results you launch through the 𝗂 user interface. In conclusion, we have to consider that 𝗂 use and manage XAI library in plugins. This has three important consequences. The first one is that 𝗂 does not make explanation itself. The second one is that you will not find a complete documentation of these methods and metrics in the 𝗂 documentation. Links of these libraries are provided. You have to see their documentation on their repository or for more information about them. But the most important consequence is that the 𝗂 installation depends on the compatibility of all installation of the XAI library and their respective dependencies. For that, currently only Python 3.8 can be used to be sure that all libraries can be used together. This problem of dependencies and limitation and the limitation to Python 3.8 is identified as an urgent evolution. The second evolution concerns the plugin development. The 𝗂 documentation explains how to use 𝗂 and its components. In 2 dedicated chapters, there is a description of how to create plugins for your use case and your XAI library. But we consider that the main part of the Python code and of the plugins can be automatically generated according to answer some question about dataset and model. It will be a major and useful development. Actually, 𝗂 is a benchmark tool that is more a benchmark tool than the comprehensibility tool. The third evolution we propose is to work on this part of the scope by enriching 𝗂 usage with knowledge about metrics and methods and recommendation we reported during the 𝗂𝗽𝗱𝘁𝗂𝘁 program. This to explicit explanation, as we saw with Renault welding problem. We are sure that with this evolution, some explanation will be easier to understand and comprehend. So thank you for your attention. I apologize, but I have to leave you for another meeting. So if you have some questions, feel free to send me an email or to the association. Thank you.